Hello everyone.
Hello everyone. Am I audible?
Yes,
Yes,
you
sir,
are.
audible.
Yes, sir.
Okay, great. So how sorry, how was your quiz 2 exam?
Great, sir.
Great, nice. Paper was easy, medium, or difficult?
Medium.
Medium, okay.
Medium.
Easy, sir.
Good, easy, medium. Okay, nice to see that. Yeah. So
Sir,
today we'll bolo.
sir, but some questions which I have practiced lot of times.
Hmm.
One, two question which I have made wrong.
Yeah. You have practiced, you have made it wrong, right?
Yeah.
The reason I will tell you. Okay. See. Uh. Okay. How many of you have solved week 10 practice assignment question? Just raise your hand. No one. Yeah. Very good. So see, today we are going to discuss that only, week 10 practice assignment solution. Now, what Divya said, right? So he practiced many
इसमें
times,
सर
but hello,
सर एक डाउट था।
yes,
सर मैंने मेकअप एग्जाम के लिए वो करा था, फॉर्म भरा था, तो वो मेरा दिसंबर में ही है ना, 22 को।
for re-attempt qualifier exam.
नॉट क्वालिफायर। एंड टर्म मैं उस दिन एब्सेंट थी एंड टर्म एग्जाम पे।
Yeah, okay. End term to 2nd December को ही है, right? Not
एंड
2nd December. No,
सिलेबस
22nd.
कौन से वीक तक होगा?
For end term syllabus is all week 1 to 12. Entire syllabus.
थैंक यू सर, थैंक यू।
Yeah.
मतलब सर जो
So,
क्वेश्चन था वो
हाँ,
आपको आप भी दो तीन बार करवाए थे। उसी क्वेश्चन मैंने गलती किया। मुझे याद भी आ रहा था कि ऑप्शन 2 और ऑप्शन 5 करेक्ट है इसका।
hmm,
लेकिन मैं 2 और 4 करके चलाया। लाइन 2 और
yeah,
4। इससे
yeah.
बढ़िया।
See, the reason I will tell you. So, what happened? What most of you do? We have GA and PA, and I many times told you that you have to practice GA and PA. So you don't you practice. I know you all solve GA and PA, but after deadline is over, most of you try to attempt GA by looking at the previous solution or from YouTube and then submit. Similarly for PA तो कोई solve करता भी नहीं होगा, right? But you solve all this question just before the exam and you think that okay, we are solving this question, but actually not. The reason is that you already know the correct answer for this. Even if you have not looked at the solution, even if you know just the correct answer. For example, this question number one. I know I have directly looked at this particular, okay, A and C are the correct here, right? I already know this correct option here. And even because when you solve GA, answer is given to you after a deadline, right? So you know that the answer of this particular question is option number A. So while solving this question, you have that thing in mind. So you're not actually finding the correct answer. We're actually trying to get that correct answer, right? So there is a difference between finding a correct solution and getting to that correct solution. Since your mind already knows that option B is correct, so you are not finding a correct solution there. You are only trying to reach that particular solution, right? So in this way, what will happen? You are not exploring all the possibility of those questions or those options. Okay. Same thing happened with me also. Even if I want to take these questions, right? I already know the answer, but I don't solve the question before coming to a session. Like you must have observed, I also make many mistakes, right? This is because I don't solve the questions before the session. And same reason, if I know the answer, okay, option A is correct. So while teaching this particular concept or question, I will get biased to that particular option. I will not able to teach all the options, why it is not correct, why it is correct, right? So we are not finding the correct answer here. We are just trying to get that correct answer here if I already know the correct option. So that's why I will suggest you to solve PA and GA without looking at the correct option. And best way to solve GA is before the deadline. Solve your solve by your own, right? So most of you look at the previous year solution or from YouTube, you just submit the options, that's it. And then after some time you are going to solve those questions or before the quiz. So that is not going to help you, right? So this is the reason behind that. You may think that you are solving the question, but actually you are getting to the correct answer, not finding the correct answer. So there's a difference, okay? I hope this makes sense, right? What I said.
Yes,
Yes,
sir.
sir, you are absolutely correct.
Uh, Because if you see, I know now this option is A, right? So even while going through the pseudocode, I know what this ij represent. So directly I can conclude that okay, this particular thing will be this particular thing will be this, and here I will get the option number A like this. So I'm not solving the entire pseudocode. I'm not going to pseudocode. I'm just trying to connect how I can get that particular correct option here. Okay. So please try to solve the questions
Hmm.
before the deadline. That will
Because in that case, we are not using our concept and our brain.
yeah. You are just trying to get that correct
Hmm.
answer, not finding the correct answer. Okay, so please try to solve the questions before coming to the sessions. Okay, and best way is to solve a GA. We are providing the weekly practice assignment solution. We are solving those in the live session, but GA we are not doing that. So we expect to solve GA by your own and before the deadline. Okay, that's how this course is structured. Okay, so please keep this in mind. You have to submit a GA before the deadline and solve by your own. Don't look at the YouTube solution or previous term solutions. Okay, let's solve the question now. So this week 10, so we have very less time for week 10. So directly I'm going to explain the practice assignment because Wednesday is the deadline for this. And if you observe, it is just application of what we have discussed in week 9. Graph, then we have graph and dictionary, those adjacency matrix and all those concepts. Let's try to solve this question here. Consider the following condensed version of trains dataset. So whatever the trains dataset we have discussed, same thing is given, but in a different format here. There are n stations, with stations being indexed from 0 to n minus 1. Okay. There are m rows in the table. Each row contains information about the two stations without any stops in between. So this table is given to us. For example, rth row tells us the train T depart means from station I and arrives at station J, right? After covering distance D without stopping at any intermediate station. It means that that train is directly going from I to J and traveling that particular distance D without stopping or without going to any intermediate station. Okay, remember this point. In other words, the RF row in the table correspond to two consecutive rows in the card for the train T in the train's dataset. Therefore, each train will occupy the multiple rows in this table. Now, tell me what is the meaning of this entire paragraph. If you understand what this thing, tell me the meaning of this entire paragraph. Yes, anyone? Let's say I have n station. Now, let's say I have five station here, right? So let's say I have Delhi, Mumbai, Pune, Chennai, Bangalore. I have five station here, right? So n equals to 5, right? And here I have the sequence number, the train number, departure and arrival. And each station being indexed from 0 to n minus 1. So if I have this six stations, so they are indexed from 0, 1, 2, 3, 4. So 0 means what? Delhi. 1 means what? Mumbai. 2 means what? Pune. 3 means what? Chennai, like this. Now tell me the meaning of this one. Where it is? Yeah. If you understand this, tell me the meaning of this particular last sentence and it corresponding to this particular sentence. See, what this table is saying. Suppose I have one train. So if you remember, we have one train 12282. Now let's say that is going through Delhi, then going to Mumbai, then from Mumbai going to Pune, and from Pune going to Bangalore like this. Okay, I have this train 12282 going from Delhi to Bangalore. How many stations we have? Four stations here. Index is what? 0, 1, 2, 4, right? So we have four station. This is the index number. Now, how we are going to represent this in terms of this particular table here? See, so what they are saying, each train will occupy multiple rows in this table. The reason behind that, when we say I to J, it means that 0 to 1. What is 0 to 1? Delhi to Mumbai. Delhi to Mumbai, I'm going through without any station, without any intermediate station, and traveling 260 distance. So 0 to 1, that is Delhi to Mumbai, I'm going to direct this much distance. Also here, Mumbai to Pune, same train number, let's say 12259. Same train, Delhi to Mumbai, and also Mumbai to Pune. Same train will go from Mumbai to Pune, some distance. Again, same train, 1225 number will go from Pune to Bangalore with some distance D. Right? So we are representing this particular train going through Delhi, Mumbai, Pune, Bangalore in tabular format. And here train number can be occupy multiple rows because Delhi to Mumbai, one row, then Mumbai to Pune, one row, Pune to Bangalore, one row, and each distance is given to us. So this is 266, say 300, let's say here 700 like this. Okay. So that's why here you can say in this particular table, we have multiple rows occupying the same train number. And here it is representing the distance between two stations like this. Okay. Any doubt now? What is the meaning of this or any confusion? Okay.
Sir, then sequence number would be the departing station, right? Like from
Sequence number is just a row 0, 1, 2, 3 till m minus 1. So it is mentioned that
okay.
m are m rows in the table. Yeah, that's it. Okay. So we have n station and that is already given to us. So this scenario is modeled as a graph represented by matrix A. Each node in the graph correspond to a station. Assume that the value of n is already given to you. And let's say, for example, we have n equals to 5. And when I say 0, 1, 2, 3, 4, these are the node of the graph. And when I say Mumbai to Delhi to Mumbai, so there will be H like this. Then Mumbai to Pune, there will be H like this. So when I say 0, 1, it is basically Delhi, Mumbai like this, right? So this will look like this particular graph, right? So directly 3, 2, 4. So 3 to 4. And let's say we have one more train, 1, 2, 2, 8, 9, going through Delhi, then Mumbai, and directly Bangalore, like this. So that will go through 0 to 1, yes. Then from Mumbai to Bangalore, so 1 to 4 directly. So this represent the route of that particular train. This represent the route of first train. So that is the graph uh, given to us. But here we have just considered n equals to 5, 5 stations here. Okay. So let's consider that particular graph. So here I'm just writing down the sequence, sorry, numbers, so that will be good. Or I can simply write down the Delhi name as well. So Delhi, Mumbai, Pune, Chennai, Bangalore. So this is basically a node, and here you can see we have a train between like this I to J. Okay, so let's say this is a graph, and in the adjacency matrix, so if I have this n a node, what is the adjacency matrix for this particular graph? So we'll discuss it here, don't worry. But this is the scenario given to us. Simple, nothing much complicated. We have one train going through this much stations. We have just tabulated in this particular format that from going to this station, this much distance it will cover. Then from Mumbai to Pune, this much distance it will cover. From Pune to Bangalore, this much distance it will cover. Same train, right? We have a multiple station for that particular train number. So this is a given to us. Now let's try to solve the question. Simple question. So here we have S, that is empty dictionary here. While table 1 has more rows, table means that particular table. Read the first row X in table 1. So what is this? Tell me what we are doing here. So we have the
Dictionary,
enough
sir. We are
practice
maintaining
for,
a dictionary according to the sequence number, sir.
yeah. So if you observe what we are doing here, I have S. For that particular first row, we have a sequence number as a key, and then we have one more dictionary. Can I write like this?
Yes,
Yes,
sir.
sir.
Then after this, what about line 5, 6, 7, 8? What we are doing here?
There will be another.
Creating dictionary,
Yes.
train name, departure and arrive time.
Then what is this? Like a new dictionary, or it is a key value pair for that empty dictionary what we have created
Key
here?
value pair for that
Key
empty
value
dictionary.
pair, sir.
So for that sequence number, we are going to store the train. So train and the corresponding x dot train. Whatever the value, let's say 1, 2, 2, 8, 9. Then departure. Let's say we have Delhi. Then we have arrive. Let's say Mumbai. But here we are representing by a number, say indexing by number 0 to n minus 1. So what we have done 0, 1, 2, 3. So instead of Delhi, Mumbai, I will represent my 0, 1, 2, 3. So if you observe, this is what we are doing here. So let me complete this, then I will come back it here. So instead of Delhi, Mumbai, I will just mention 0 and 1. So this is 0, this is 1, and where it is? Yeah, arrival, then distance. Then again, comma, then we have a distance, and whatever the distance, what 266. This is for the first row. If you observe for a sequence number, so we have that sequence number 1, sequence number 0, sorry, then train number. So 0 is there, then we have that particular key. Then train number is there. So train is what? 12259, then comma, departure 0, comma, arrival 1, comma, distance 266. So we are storing this tabular data into a dictionary, right? Can I say like this? Because we are doing this for every row. While loop is there for table has more than one rows. For every sequence number, we are creating a dictionary. For every sequence, we are creating a dictionary. And in that dictionary, we are adding train number, corresponding train number, departure, corresponding departure, arrival, corresponding arrival, that index value, and in distance, corresponding distance, right? This is what we are doing for entire table. So we are simply converting that tabular data into a dictionary here. Any doubt
Yes, sir.
here, right?
Clear,
Okay.
sir.
Okay. Now, see, this is what a S will be for the first row. So what I'm going to get, so this will be there for 0, 1, 2, 3, for whatever the number of rows we have. For that, corresponding to that, we have this entire thing repetition, right? So this is what this while loop is working, and it will convert this data in tabular format to a simple dictionary S. Okay, if this thing is clear, now see what is here A, create matrix n by n. So let's say we have n equals to 5 station here. So it is going to create a matrix of 5 stations. I hope everyone knows the matrix 0, 1, 2, 3, 4, 5, what we have create adjacency matrix. So instead of Delhi, Mumbai, I'm just mentioning the index value 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So 0 indicates Delhi, 1 indicates Mumbai, like that, right? Here you can see. Now for each R in rows of A, what is rows of A? What is columns of A? Yes, anyone?
Sir, rows will be the station where it departs and columns will be the station where it arrives.
Uh, yeah, you can say that, but this will give me the list of the stations, right? Anyway, rows and columns is 0, 1, 2, 3, right? So we will get the information about that from this matrix. your observation is correct, but this represent the list of the station like 0, 1, 2, 3, 0, 1, 2, 3, right? Rows of A is what? This particular thing, rows of A is 0, 1, 2, 3, 4. Columns of A is what? 0, 1, 2, 3, 4, right? So this will give me list of the station, and we are representing by index value, so 0, 1, 2, 3, 4. Now what is this A? So we are creating a A, so already a matrix is there, that is this matrix. Now RC, so for this R, when we say R equals to 0 and C equals to 0 for the first iteration, we are creating a empty dictionary here, and this is for all the things. So for all the pair of station, we are creating an empty dictionary like this. Okay, so when we create a matrix of n by n, it was 0, 0 initially. Now we are updating it to a simple this curly braces empty dictionary. Anyone, any doubt in this part? How we are converting a matrix to this dictionary values?
No doubt, sir.
Yeah, so initially we have just this 0. Now we are updating it to a empty dictionary for each thing. So for each pair of station, it will be a empty dictionary, right? Now let's say I have this empty dictionary here. Let me use different color. This for 0, 0, 1, 0, 1, 0, 2, 0, 3, 0, 4. Okay. Now for each X in keys of S. Now what is keys of S? Tell me.
Sir, sequence number?
Yeah. So here we have sequence number, that is correct. But keys of S will be a list of sequence number, right?
Yes, sir.
Of all the sequence number. So that will be whatever we have number of rows in this particular table. Okay. Now for that particular sequence number, what we are going to do? R equals to what? S for that sequence number departure. For example, S0, and for departure is this one. So we are going to store it in the R. So R will be 0. C is what? S for that particular sequence number. Arrive is what? 1 here. Let's say for example 1 here. So it is 1. T is what? Let train 12289. So that will be 12289. D for that sequence number distance is what? 266. So whatever the data we have converted to a dictionary, same thing we are storing in a different variable here. R means a departure, C means arrival, T means train number, D means distance for that X station. Sorry, not station, for that X sequence number, right? And now here we have A, R, C, T. Now A represent this particular matrix. RC is what? 0 and 1 here. We got this. So for 0th row and for first column here, what we are going to do here in this empty dictionary? Tell me, what is this? D is 12289, D is 266. Tell me.
Sir, a dictionary with train name as key and distance between two stations as value?
Yes, yes, yes. So here we are going to update it by like this. So here it will be a train number, that is
Sir, could you
12289,
repeat the last step, sir?
distance 266 like this. Okay. So see, okay, you understood about the matrix A in the previous
Yes,
steps?
sir. The last step, sir, the
Yeah.
updating.
So here we create matrix for each for n. So n by n for a number of stations, and R and C represent the number of like list of the stations. And initially it was all 0, so we have updated to empty list. Sorry, empty distance. That is fine. Now here what we are doing for each X in keys of S. Keys of S is what? Sequence number. So list of a sequence number here. Now for that particular sequence number from that dictionary, R represent what? Depart. So departure is what? 0 here. C represent what? Arrives, the value of S, that particular sequence number, and that arrival is what? 1 here. Now for T, for that particular sequence number, train number is what? 12289. So 12289. And for that sequence number, distance is what? 266. So 266. Now what we are doing here? We're updating a dictionary A such that RC represent the rows and column. So R is 0, C is 1. So 0th row and first column, initially there was an empty dictionary. Now we have to update with this. Now 0th row, first column, dictionary. Then what is T here? Train. And value corresponding to that is D. So inside that dictionary, empty dictionary, train will be the key and the corresponding value will be the distance like this. So 12289, distance is what? 266 like this. Are you
Understood.
getting my point? Right?
Yes, sir. Clear, sir.
Now
Sir,
if you understand,
here R and C are represent A, R, and C are representing a matrix, right? If we add like the same square bracket to T, like will it represent a dictionary? Yes, sir, over there. How to identify it is a dictionary that we are updating?
see,
Like,
A is the matrix we already know, we have calculated, right? When I
yes,
say
sir.
A is a matrix, so it will have rows and column, right? And we always represent matrix like this A, I, comma, J. It means that ith row and jth column, and that particular value will be something here. So here ARC means what? 0th row, first column. So that is basically what empty dictionary was there. Output of this is what empty dictionary. But we have T here. So T equals to D. So we already know that it is an empty dictionary. So T will be the key here and the corresponding distance will be the value for that dictionary. Right?
Okay, sir. Now I understood. I was getting confused that it is also a value of matrix T because the same square brackets are used. I couldn't.
So this represent the dictionary, right? And now
Yes,
if
sir.
you see dictionary, then
Understood, sir.
corresponding, yeah. So here D, then we have corresponding key, then corresponding value like the same state. Instead of D, that is AIJ. That's it, right? So this is about the pseudocode. Now, if you understand pseudocode, if you understand what A will represent for each row and each column, you can easily answer the question number 1. If IJ is the pair of a station, which of the following statement regarding dictionary IJ are true? Now, IJ is what? Here, the index of that particular station, right? So let's see the option. Each key corresponds to a train that goes from station I to J without stopping at any intermediate station. So key represent a station here or not for this dictionary? Key represent a corresponding to a train. Yeah. So each key correspond to a train. Is that true?
Yes, sir.
Yes, sir.
Yes. So this is what we got, right? Each for each that field we have a train and then corresponding value is what? Distance. So key is train. So each key correspond to a train that goes from I to J without stopping at any distance. Yes, this information given in the question itself. And here train that goes I to J but stop multiple. No. C is what? The value corresponding to key T of a dictionary is the distance between station I and J on T's route. Is this correct? Or read option number D. The value correspond to T is minimum distance between station I and J on T's route. Value corresponding to T is what?
Option C, sir.
Distance, right? Distance between I and J on T's route.
Yes, sir.
So option A and C will be correct. Here minimum is there, but we have not compared distance, right? There is no comparison in the pseudocode. Less than, greater than, no. So we cannot get the actual data for minimum or maximum. So option A and C is correct. Anyone, any doubt here in this question? Okay. Let's try to solve the second. Tell me the answer for this now. If you understand what this A represent, you can easily answer this question now.
Option B, sir.
Yes, sir. Option.
Option number B. Okay. So here Aij, we know what is this matrix Aij represent. So for each row and for each column, we have corresponding value in dictionary. In that dictionary, we have train number and the corresponding distance. This is given to us. Now, when I say keys of Aij, so keys of Aij will be what? keys of this particular dictionary. That will be a train number, right? And length is what? So length is what? Length of the key. How many train number are there in that particular for that row and column, right? So let's see. A is what? Number of trains that go from station I to J. That stop at least one. No. Number of trains without stopping in intermediate station. Okay.
Yes, sir.
Option B is correct. Number of
Yes, sir.
trains that go from J to I, not J to I. Number of trains I to J, at most one. We have not considered any condition for this, so we cannot sure. So correct option is option number B here. Right. So simple question for this two questions, right? Based on this pseudocode. Any doubt? Okay, so let's try to solve this third question. I will just come back in 1 minute.
Please show the error line.
Yes, tell me what the pseudocode is doing. Here we have a procedure that accept Aij as a pair of station and matrix A like what we have calculated in the previous question that as an input. It returns a train goes from I to J by covering the least distance, right? Without stopping at intermediate station. If there is no train connecting these two stations, the procedure returns 1. Okay, this is the procedure that returns 1.
-1, sir.
I'm sorry, -1. Yeah. The may have mistake and we need to identify them. So if there is no train between two stations, then procedure returns 1. So here we have procedure. So Ij and that particular matrix A, if length of keys of Ij. So keys of Aij is what? For that particular station number, let's say 0, 1 or any 2, 3, 1, 3, anything. Keys will be what? Train number.
Train number, sir.
And length of the keys what? Number of trains. Can I say like this?
Yes, sir.
If
Sir,
this
could you repeat what did you say just now, sir? Like,
keys is basically train number, right? We know this.
yes, sir.
And length of that will be number of trains,
Yes, sir.
right? So keys will give me a train number and length of that number of trains number of trains for these two stations, whatever the I and J will be. If that is equals to 0, it means that there is no train between I and J. Can I say like this?
Yes, sir. It's an empty
If it is,
dictionary.
yeah, if it is an 0, so it is an empty dictionary, there is no train number. So it is if it is equals to 0, it means there is no train between I and J. If there is no train connecting these two station I and J, it should return what? -1.
-1, sir.
Now what is returning here?
False.
False.
So that is
Line
not
3 is
correct.
wrong.
It should return -1, right? So line number 3. Now let's say if we replace this false or -1, then it will look correct because length of keys will give me number of stations, sorry, number of trains for these two stations, right? Now, but if it is 0, so it means there is no train connecting these two stations. So return will be -1. Now this is one mistake. train first of keys. Now, what is first of keys? Tell me.
Where it gives the
First train, sir.
first train.
So here keys will be a list of the train number, and first will be the whatever the first train going from these two stations, right? So train number will be that. Okay. Mean will be what? AIJ. So for that particular station, for that particular train, whatever the distance we got, because what we got A, R, C, then we have D, and then sorry, we have T, and then we have D. So this is what it is given, right? The question ARCT and corresponding value is T. So for that row, for that column, is for that station I, for that station J, we have a dictionary. In that we have a train number T corresponding to the distance. So if I put it same here for RC, for that train number T, distance will be the minimum. So let's say we have 0 I and distance is 266 for train number 12289. So same thing here, train number 12289, it will be 266. For each K in rows of this one, again rows of this will be a station number 0, 1, 2, 3. Rows of this particular matrix will be uh, that one, right?
Yes, sir.
Sorry. Now tell me, is this correct?
No, I think that it returns a dictionary for
What
each
question,
K
sir?
in
Can you
rows.
please repeat?
No, what is this correct? Rows of A, then IJ. What is AIJ?
It's in dictionary, sir.
It's in dictionary. Rows of dictionary, do we have anything for that?
No, sir. No.
No, no.
No. So that is not correct. So instead of this, what it should have?
Sir, why this is not correct? Can you explain, please?
So A of IJ is what? Dictionary here. Output will be dictionary, right?
Yes, sir.
That is T and the corresponding distance. But do we have the correct rows here? Rows for the matrix is present, right? Not for that dictionary. That is not a correct syntax here. We represent rows for that particular matrix M or A, not for any dictionary, right?
Yes, sir. Got it, sir.
So it should be for each keys of
Ah, each
like
for
that, sir.
each K in keys, right? If
Keys
I
of
replace
yes, sir.
by rows keys, then that will make sense because it is a dictionary, and keys of that will give me a list of train number, right? And then for every train number, we are taking a distance. So same thing for that distance for that station I, for that station J, K is basically train number. Then we are going to take the distance. So let's say for same thing 0 and 1 IJ distance 266. And then we are comparing distance is less than that minimum distance or not. And then we are updating the minimum distance to that particular distance and train to K. In this way, we are repeating this particular uh, for each loop. And what we want to do, same thing, right? So we want to find out the least distance, right? And we should return -1. So we have corrected line number 3. We have corrected line number 7. Now, is this returning the train? Yes, train number that
Yes,
is
sir.
uh,
Seventh. What did you write, sir? Seventh line,
seventh line.
sir.
Yeah, okay.
No, I understood the meaning, but what did you write there, sir?
Here, keys.
Okay, got it, sir. Thank you, sir.
Because AIJ represent a dictionary, right? And the row is not a proper syntax, right? It is not correct.
Yeah.
When I say AIJ is a dictionary, keys of dictionary will give me list of the keys. That is a list of our train numbers. So for each train K, we are taking a distance from those two stations, right? For example, 12289, we say going through Mumbai and Pune here. For this train, 0 and 1, 0 is Delhi, 1 is Mumbai, distance is this particular thing. So you have taken this example, right?
Yes, sir. Thank you, sir.
So keys will be a list of the station, list of the train numbers, right? And for each train, we are taking a distance, and then we are comparing with the minimum. So for example, we have initialized with the first train, and then we are simply comparing with. Let's say previously it was 266, so 266 less than 266, not correct. So go for a next iteration. Next iteration, let's say j is basically 2. Let's say we have a distance uh, minimum, right? So let's say we have a distance 200 here. Now distance is 200. 200 is less than 266. Yes, that is correct. Then we are going to replace it by distance. So minimum distance will be again 200 now, and train will be that particular train number. If I again go, if there's minimum distance, so that will get updated. So in this way, I will get the minimum distance here, right?
Sir, is it between the same stations or different stations? Like,
Different stations,
okay,
but for that train number, we are comparing for each for that train number. We are comparing the no for same station. We are calculating. Yeah, AIJ is same here, right?
yes, sir. Like for
So
zero
for
one, for different trains, which train will be reaching in the minimum distance, we'll
yeah,
update that rate
yeah,
rate.
if we have Delhi, Mumbai 01, so there are multiple trains going to Delhi and Mumbai, but which one covers the minimum distance, right? So that train number we are going to store here, and distance will be like this. Suppose there are four trains going from Delhi to Mumbai, and each train goes 200, 300, 250, 250 and 266. The minimum of that we are going to store in a distance, and that particular train number will be here, right? Like this. So in this way, we are finding out the distance, minimum distance, and the train number to those stations, I and J, and we are storing the minimum distance. So what we want to return, so this is correct up till here, but it is returning the train. What we want, it returns a train which goes from I to J by covering the least distance. So that is correct. So it will give me the train number. So everything is fine. Only we have 3 and 7. Let's see. Option number A, error in line 3. Option number D. Do we have any other? Let's see options. A and D are the correct ones here. Okay. So you can go through option wise also. Line number 3, error line number 5 or 6. So please go through this
Sir,
particular thing.
could you give any suggestion for solving mistake finding questions? So like it's like more of intuition based. Like
Hmm.
sometimes we are able to find correct
Huh.
answer sometimes.
So first we have to understand our requirement, what is given in the question, right? So -1, it should return, but what this procedure is doing, right? So you can break down this problem statement. This is a problem statement. This is a required thing. We have to break down this. Okay. So here we have some keyword least distance. So make sure that in the pseudocode, are we covering the least distance or not? So if you go here, we are comparing, then we are covering least distance. Then if you observe there is no procedure, so it will return -1. Is this procedure doing that? So read the question, break down in multiple things, and then try to map that. Okay, this is the one approach. And also you can see the options here. There's any error in line number 3. If any line number is not mentioned in the option, it means that is the correct one. You don't need to worry about line number 4 or 1, 2, because that is not mentioned here, right? So 1, 2, and 4 will be not a wrong line, right? There will not be any error. So what are the options are there mentioned? That is only we have to check. Okay, so 3, 5, 6, 7, 8, 9 like this. So the first thing is you have to break down the question, your requirement, okay, and then try to map with the pseudocode.
Okay, sir.
So this is the for question number 3 here. Okay, simple one. I can simply change this to a least distance, but if I just change this arrow to here, so line number 9 will also be an error, right? In that scenario. So you can expect such things. So please try to solve this question again. Okay. Now let's move on to question number 4. This is simple. If you didn't understand previous 3 questions, still you should be able to answer this question. Okay, I am not going to solve this. Just take 1 minute and see what this pseudocode is doing. We have this ij pair of station. Let's say any station ij. Which of the following statements are true? Execute the given pseudocode below. I to j false, t to j false, then I both j false. Then we have this if condition here, right? So if you see here, I to j is basically false. So keys of aij not equals to 0. Again, what is this length of keys of this particular AIJ?
Number of trains, sir.
Yeah, so number of trains going through I and J, right?
Yes, sir.
If it is not equals to 0, what does this mean?
Like there should be at least one train going.
Yeah, so there should be at least one train I to J, right? If that exists, then
Yes, sir.
if this is true, then I'm going to update it to true, right? I to J will be true. If there exists a train I to J, can I say like this?
Yes, sir.
If there is no train, so that will be 0, and 0 not equals to 0. Is that true? That is false.
No, sir. False.
So false, we are not going to update this to true. So this will remain false. Now same here, J2I equals to false. Here also same thing we are comparing. If we have any train, number of trains from J to I, if that is not equals to 0, means if we have some train going from J to I, again we are updating it to true. If there are no trains, so that will be false. So it will be a false only. Now what we are doing here? I both J. Now here I both J equals to false, and here I to J and J to I. It means we have a train from I to J as well as J to I. I have a train from Delhi to Mumbai and Mumbai to Delhi as well. Then in that scenario, I will say I both
Sir, it
J
need not be
equals
the
to true.
same train, right?
No, not the same train. Any train. Okay. We
Okay,
are
sir.
not comparing the train number here. We are simply checking whether this train exists or not, right?
Yes, sir.
Now, what about option number A? If there is a train from I to J and J to I is not present, then I both J is true.
False, sir.
False, sir.
Anyway, this condition will not
False.
become true. What about B?
True, sir.
Both are true. Yes.
Yes, sir, it is correct.
So option B is correct. What about C?
Yes, sir, C is also correct.
I to J is true. Because I can go from Delhi to Mumbai, Mumbai to Delhi. It means that there is a train exists, right? So C is also correct. What about D?
Sir, it is false.
D is correct, sir. D is correct, I think.
Is false.
It may be.
So if there is or in place of and, then it is correct.
Now, what it's saying, if I both J is false, means it is false, right? So here you can see this is remains false. It means this condition remains false, right?
Yes, sir.
Now, IOJ is false and TOJ is false.
Sir, we can't say no. No, sir. J2I
Yeah,
may be true, right?
yeah, J2 may be true. In that case, also that will be a false as well, right?
J2I, we can't say it is false, right, sir? Like 100%.
Yeah, so there are three possibility for false. Either we have train, but we don't have train for this. We have train for this, but not for this, or we don't have any train going to this. There are three possibilities. This is one of the possibility. Both are false, right? So
Yes,
reverse
sir.
is true. If I to J is false and J to I is false, then we can say I both J is false.
Yes, sir. We
But
can't say if from
uh,
both, like for 100% sure it's not. It might be
yeah, so
true.
if you look at this expression, if both are false, then I can say this is false. But if this is false, I cannot say both are false, right? One of them can be true.
Yes, sir.
So true and false again can be false, right? So option D is not correct. Yes, option D is not correct. What about E?
So it is
Correct, sir.
also not correct.
Yes,
Not
sir.
correct.
We
Same logic,
can't
we
say,
cannot conclude. Huh? Again
we
here,
can't conclude
same thing.
from reverse, sir.
What
Yeah,
about
all
G?
the options. Yes, sir. G is right
Yes,
because
sir.
R
Yeah,
is there.
D is
or is
Option
there.
also
is
Yeah.
correct.
So here we are saying if I both J is false, it means that either this is false or this is false, right? This is true. So option A, B, and sorry, option B, C, and G is correct one here. Okay. So B and C, G are correct. Simple question. We just need to understand how this if is working. That's it. Right. Any doubt in this question, anyone?
So it's clear, sir.
No, sir.
Okay. Question number 5. So we have sum proc is a procedure that accepts three parameters: train, station, and the matrix A that was computed in the previous
Sir,
question.
once could you go to previous page, sir?
Okay. Hmm?
Uh, okay. My net was not working, so sorry. Done, sir. You can.
Okay. Now, which of the following statement about its return value are true? So you have procedure, train, station, and the matrix A. So remember what that matrix A was. For each R in rows of A. Rows of A is what? Station number, not station number. Station name, but we have an index 0, 1, 2, 3, right? Rows of A, that is station only. Is key. So A for that row, for that station. Okay. We are checking whether this should be train. Okay. Spelling mistake is there. We are checking whether that train exists in that between those two stations or not, because it is the key, right? So if that is true, then only we are proceeding with this. Okay. You understand this? What if condition is saying here?
Yes,
This is
sir.
basically train, right? So this
Sir,
will give me
matrix A is which
same
matrix, sir?
like what we have got earlier. So that is A, R, then we have C, then we have E, then we have T. So this will give me for that particular station number, and for that another station, two stations R and C represented by 0, 1, 2, 3. We have a dictionary value having train number and the corresponding distance T as a value, right? So this is what we got in first question. So same A is considering here as well. Okay. So if you observe for that station, for those two stations, we are checking whether that is a key or not. So that train number is key or not. So here train number is key or not. If that is true, then we are proceeding here. So what we are doing for each C in columns of A. Again, columns of A will be what? Station index 0, 1, 2, 3, right? Is key. So here we have a station. For that particular station, and for that C, for which C value we have a train. If that is true, then we are going to return false. Otherwise, return true. Okay. And yeah, we have to do this for all four. And then if we have, otherwise, if it is not the train in that between two stations, we are directly returning the false here. This is the procedure is doing. So what's the here? Returns true if station is a starting station for train. Returns false if station is a starting station for train. Okay. Let's try to take one example. Let's say I have just have three stations: Mumbai, Delhi, Pune. So index 0, 1, 2. Matrix will be like this: 0, 1, 2, 0, 1, 2. Let's say I have three trains. Let's say 1, 2, 2. This is going from Mumbai to Delhi to Pune. I have 1, 2, 2, 1, 2, 3 going from Mumbai to Pune. Then I have 1, 3, 3 going from Pune to Delhi to Mumbai. Let's say we have 1, 3, 4, 1, 3, 1, 2, 2, 1, 2, 3, 1, 3, 3, 1, 3, 4. Then let's say anything we have going from Mumbai, Delhi to Pune, then Mumbai, like this, right? So this is the train number, and here Mumbai represents 0. So 0, 0, like we have an empty dictionary for that particular train number. So 1, 2, 2 will be what? Mumbai to Delhi. Mumbai is 0. Delhi will be here. So train number will be there. And let's say distance we have 500. Here let's say 200. Right? So that particular distance will be 500 here. Right? Again, let's see for do we have that pair train going from Mumbai to Delhi. Do we have any other train here? Mumbai to Delhi? Direct train, Mumbai, Delhi, Mumbai, Pune.
No, sir.
No, right? Delhi, Pune, Delhi, Pune, Delhi, Pune. Okay, Delhi, Pune, let's take. So Delhi, Pune is 1 and 2, right? So yeah, for first row, second column, Delhi and Pune. So let's take 1 and 2. So 1, 2, 2. For that, it will be like this 1, 2, 2. Distance is what? Delhi to Pune, 200. Now, do we have any other train here? Delhi to Pune?
No, sir.
Here you can see
Ah,
now
yes, sir.
1, 3,
134.
4. So again, we need to add here. So I will going to update that dictionary. So that dictionary will like this. 1, 2, 2 will be 200. 1, 3, 4 will be whatever the distance. Let's say here we have 600 like this. Okay. Here we have 600 like this. So here we got two train going from Delhi to Pune like this. So let's try to take the same example here. So we have a train. So let's say that particular train station. Station is given. So let's say station is Delhi. A is that particular matrix. Train. We do we have train number? Yeah, let's say 122 is a train. Now let's see here R in the rows of A. Rows of A will be 0, 1, 2. Is key station number. So first we're going to check whether Delhi is in R. So for the first value of R is 0. So for 0 and that particular station is Delhi. Delhi is what? 1. So 0, 1, 0 and 1. Do we have that particular train? So we are
Yes,
going to
sir.
do 1 to 2. Yes. If that is true, then we are again checking for each C in columns of A. So again, columns of A will be 0, 1, 2. So again, C will start from 0. Now that A station number is what? Delhi. So Delhi is what? 1. So 1. C will be starting from 0. So 1, 0. Do we have train? What the train was 1, 2, 2.
No,
So
sir.
we don't have. We just have here second time. So
Sir, is
no.
it from 1 to 0, right?
1, 2, 0.
From
1, 2,
columns.
0. Yeah. But
Reverse
do we
order.
have? No, no. Here station is already fixed. Input is station, right? For this
Yes,
procedure,
sir.
train and STN is the input. So we are saying train number is 1 to 2, station is Delhi. So that is basically 1 here, right? Instead of Delhi. So if I say this is 1, everywhere instead of train 1 to 2. So we need to find out for which value of C there exists a train between 1 to that particular thing, right? C. So if you see for C equals to 2, I have again the train 1, 2, 2. Yes, if that is true, then we are going to return false, right? So this is how the pseudocode is working. It is simply checking whether train is present between those two stations or not, right? Otherwise, it will return false. But when it is going to return true,
Only in one direction it should be there.
only in one direction. So this will return true only when this should not return false. It means that this should be false, right? We
Yes,
are
sir.
interested in finding out to return true. So this will return true only when this will not return false, and this will not return false when this will become false, and this will become false when that particular train is not a key of that particular dictionary. It means that train is not uh, there between those two stations, right? Then only
Yes,
it will
sir.
return the true here. So
Sir,
let's
Yes,
try
sir.
to
I would like to ask you, like, for from 0 to 1, there exists a train 1 to 2. Then to make it false, there should be another same train from columns 1 to 0. Another the same train 1 to 2 should be present. Then it will be false, right?
no here sorry, can you repeat? Here station is 1 here, huh? Now
0. This value of C, sir. The same train 1 to 2 is there. Then it will be false, right?
120. Yeah, so 120. Do we have any train from Delhi to Mumbai? 120 we are saying, right? So Delhi to Mumbai. No, we don't have any direct. Yeah, here we can say Delhi to Mumbai. We have written 133. So that will be 1 out 0 will be 133. So we are checking whether that particular train exists or not. So if that
So
is true, then we are going to return false. That's it.
it is not 1 to 2 train, right? Then it will be true only, right?
Sorry, can you repeat? It is not.
We are getting from Delhi to Mumbai. We are getting the train number 133, right?
Right.
Uh, like for here to check for if case, then 122 is not there, so we can make it into true, right?
Yeah, if that condition is not correct, but we have to check for all the C values. Okay. So let's say consider this particular thing only. So here, for any C value, this condition should not be true, right? Then only I will get this true. Means they should for that station between this station, whatever the input is, and the C, means all the station. If there is a train, then it will return true. It will return false, right? If this is true. Can I say like this? If there exists a train between the C, whatever the value of C will be, and that particular station, then there will be a train. So this will become true. So we are checking whether train is a key or not for this particular dictionary. And this dictionary represents the train numbers between C and station. Station and C here, right? Whatever the input we have given. So we are checking here any train exists between Delhi to this C, whatever the value of C will be there, right? If there is a train from Delhi to C, for this particular train number, then we are going to return false. But here 1 to 3 is there, right? But we are comparing with 1 to 2 here. So if that train is going from Delhi to that particular thing, then we are going to return false. But 1 to 2 is going from Delhi to what? Pune. So Pune is what? 2. So for value of C, this will give me false, right? Delhi to 2 for this train number 1 to 2. If I just take this as an input. So what input you are taking based on that. So for this train input number, train number, and for this station, we are finding out does any train exist for this particular train? Do we have any station after like going directly to from this station, right? From Delhi to any other station. Whether this train is going from Delhi to any other station. Are you getting my point? What we are checking is this train going from Delhi to any other station. No? Okay. Okay, so we want to find out true. So this will be true only when this is not returning false. Is this fine now? This you understand, right? Simple.
Yes,
Yes,
sir.
sir.
Now when this will be return false, when this will become true, right?
Sir.
Now we want to return true, it means this should be false, right?
What's it?
Yes, sir.
If I want to
Which does
return this
mean
true,
visit particular station. Am I right, sir?
can you repeat?
It returns true when the train does not stand on the particular station. Am I right, sir?
Now this equation, this if condition you are saying,
No. Return true. I'm telling about return true.
yes, yes. This will return true when that particular train is not stopping from that station to any other station, right?
Sir.
So let's see the option here. So some prop returns true if station is starting station for train. But if it's starting station, it is going to stop at some other station, right?
Yes, sir. This option is false.
Because if it is going to stop at some other station, then this will be true and it will return false. So it should not
Yes,
stop,
sir.
yeah, from
Sir.
Delhi to any other station. So some returns false if station is a starting station for train. Yes.
Yes, sir. This is true.
True, sir.
Now tell me when this condition will become false. There do we exist any train which will not go after Delhi when it is possible? I have a station Delhi here and I don't have any station after that for this particular
Delhi
train.
should be
When
endpoint,
Delhi
sir.
should be the
Ah,
last station.
yes, yes, yeah. Delhi should be the last station. After that, we don't have any station, right? So it will return true when station is the ending station for train, right?
Yes, sir.
B and C is the correct here, or yeah, B,
Uh,
C. Yeah.
Sir,
Are you getting my point now? Huh?
sir,
Yes,
so
sir.
for
Now I got it.
122 from
Huh?
Delhi to another Pune is another train is there, right?
Hmm.
So it should be false, right?
Yeah, Delhi to Pune. Yeah, for this example, it should be false. But if I take
Okay, okay, sir.
Delhi Yeah, if I take 1, 3, 4, then in that case it will return true, right? 1, 3, 4 we don't have. Sorry, Delhi is the last station for which train? We don't have any train. Okay, don't take this example. Let's say any train having Delhi as a last station. Okay, or we can simply change Delhi to instead of Delhi. Let's take the train 1 to 2 only, but make Pune here, right? So what will happen? This is 1 to 2 Pune. Now for this particular train, do we have any other station after Pune?
No, sir.
No. So in that scenario, what is the value of C? C means what? First Mumbai, Pune to Mumbai? No. Then it will check for Delhi, Pune to Delhi? No. Pune to Pune? No. Then it will return false. So it will return false means this will be false. So anyway, we are not going to execute. We are going to return true here in that scenario, right? So this is only possible when there is no train after this particular station, right? So it means that that station is the ending station, right? So option C
Yes,
is
sir.
correct here. It returns to if station is the ending station for a train, right? If that station is starting station, then anyway it is going to stop somewhere, right? So that will return false anyway. So option B, C is correct. What about D?
Sir, it
No.
is
Wrong
false.
option, sir. It's
Yeah.
returning false.
Wrong,
Yeah.
sir.
What about E?
Intermediate station is there, right, sir?
Sir, it is also false.
Some proc return true if station is end station. No. It should be last
No, it's
station. What
wrong.
about F?
True, sir. Like it's
Yeah.
right answer.
Yes, sir, it is true.
Doesn't matter it's in which station, but if it is stopping, then it should return false, right? What about G?
Why F is true, sir?
Suppose for this train number 1 to 2, I am talking, let's say, Bangalore. Now, instead of
Yes.
station, I am having Bangalore here. Now, what will happen for Bangalore, which is not a station for this particular train?
So the
In
whole
that case,
procedure return false.
yeah, in that case, what will happen here? This will never become true, right? Because for this
Sir,
particular train
it
number,
won't even go for from first.
yeah,
From
sorry.
first.
Here,
Yes,
if you
sir.
see
First
train
also
number, we
doesn't
are not checking.
execute.
Yeah, directly we'll go to, we will not execute this one, we'll execute false here, right?
Yes,
Yes,
sir.
So
sir.
this condition
So
will
the train
become
passing
false.
through the station, am I right, sir?
Where? Can you repeat?
In the train passing through that station, is that right, sir?
No,
Uh,
here what we are checking whether that particular train uh, is going through this two station or not. If it is not, then simply we are going to exit this
okay,
if
okay,
and
got
then
it,
we are
sir.
going to return false, right? So if you
Okay,
observe,
sir.
Bangalore is not in the root of this particular thing, right? So it is not a key of that particular thing, train number 1 to 2 2. So in that case, it will directly return false. So option this must be correct. G. Let's see G. A, B, C, B, C, F, H. F is correct. H is correct, not G. Okay, it will not return, it will return false. Sorry, it is going to return false. Yeah.
Yes, sir.
So this should return false. So then it will be correct. What about F? Return, yes, that is also correct. What about H?
Yes, sir, this is correct. It will return false if there is no
Yeah,
train on
same
this.
thing like
If there
what
is
we
not
have
station.
discussed. So this is the way to solve. Anyone, any doubt in this question? Please try to
No
solve
doubt,
this
sir.
question again. See here, I have taken the example, but you can try solving without example as well, or take another example. Main key is here only, right? So you need to understand when this will return true. This will return true only, it is not going to return false. It is not going to return false when this will become true. Now, when this will become true, that we have to think. Okay? And when this will become false, in that scenario only, this will return true. So it means that there is no train after this particular station. In that scenario only, this will return true, right? So remember this particular thing. Even if you don't take the data, still you can answer this question if you understand what we are doing here. Okay. So this is a very good question. Please try to solve again. Now question number 6 to 7. A different question. Let's see. Assume that there are n stations, okay? Trains data set index from 0 to n minus 1, same thing. Consider graph with the station as node. There is an edge from station I to j. If and only if there is a direct train from I to j, right? So there is an edge from I to j in that particular graph. Only if there is a direct train from I to j. The graph represents a matrix direct such that direct I j equals to 1. If there is an edge from I to j, 0 otherwise. Okay. If there is no train from station I to j, it means there is a 0, right? There is no edge in the graph. Now station J is reachable from I if we can uh, add non-empty sequence of trains that takes a passenger from I to J. I think it is add, or what is this? We can add a non-empty sequence of a trains that takes a passenger from I to J. Okay. In other words, J is reachable from I if there is a non-empty sequence of AJs from that connects I to J in the graph. So same thing. If I go from I to J, so J is reachable from I can say. The following pseudocodes computes a matrix V of identical dimensions as direct, such as this one, if and only if J is reachable from I. All other entries of B are 0. And here direct is what? From I to J and 0 otherwise. So J is reachable from I. What do you understand by this sentence? Tell me.
Sir, is it true that if like from A to B, like from I to J, if there exists a edge, then it
Mhm.
should compulsory like then there exists a edge from J to I. Is that the meaning?
There is a direct train from I to J, sir.
No,
It's
direct train
like
we
if
cannot.
the passengers are available when the train reaches J, so it can be reversed like from J to I, like that, sir.
Yeah, so if I say Mumbai, Delhi, Pune, if I'm going from Mumbai to Delhi, so I'm reachable from Delhi is reachable from Mumbai. I can say that is correct. But if I'm going from Delhi to Pune, so can I say I'm reachable to Pune from Mumbai? Pune to Mumbai, J to I. Can I say like this? J is reachable from I. If this is J and if this is I, if J is reachable from I via Delhi.
Sir, could you repeat once again what you've written here? Just that written part.
I have a one train going from Mumbai to Delhi, and I have another train from Delhi to Pune. Okay. This graph represent like this. Mumbai to Delhi, let's say 122 train number, and Delhi to Pune is 180 train number. Right? Can I say I'm reachable to Pune from Mumbai?
Yes.
Yes, sir.
So station J is reachable from I. We can add a non-empty sequence of a trains that takes a passenger from I to J. Okay. In other words, J is reachable from I, non-empty sequence. So here I can go from Mumbai to Delhi and Delhi to Pune. It means I can say that I'm reachable like Pune is reachable from Mumbai, right? I can reach Pune from Mumbai via Delhi, right? I want to go to Pune from Mumbai, but I am going via Delhi, right? That is what B matrix is. Okay, any doubt here? See, I
Sir,
want to go
like
to,
I'm not able to understand. Like there should be a direct train. So you're going from Mumbai to Pune in two different trains, which make uh, the sense that we are going in direct trains, right? Am I right, sir?
we are going in.
Like the question says, there should be a direct train from any each station to represent the value as one. Then
No,
for
that is
going
for a
from
direct train. For direct train, it is correct. But what about this B I am saying about? Bij is what? J is reachable from I, meaning of this.
that only I'm
Direct train
not
is
able to
simple.
understand, sir.
Direct IJ is same thing. Mumbai to Delhi, direct train is there, then one. Mumbai to Pune, we don't have a age. It means I cannot go directly from Mumbai to Pune. Delhi to Pune, I have a age. It means that I can go from Delhi to Pune. So that will represent in direct matrix Mumbai to Delhi 1, Delhi to Pune 1, but Mumbai to Pune will be 0 for the matrix direct. But in the case of B here, Mumbai to Delhi, I can go. Yes, I can reach. Delhi to Pune, I can reach. Yes, but I can also reach Mumbai to Pune via Delhi First I will go to Delhi, then I will go to Pune, right? So Pune
B
is
is like
reachable from
having an
Mumbai.
intermediate, sir.
Yeah, so we are intermediate station, we are reaching to a particular station, right? P.
Oh, okay, sir.
So J is reachable from I. Pune is reachable from Mumbai if we can add non-empty sequence of trains for train number 122 and 180. So there is a sequence of a trains that takes a passenger from I to J. Okay.
Sir, could you explain the meaning of a non-empty sequence of trains? That sentence.
Means there exists some trains between those two stations, non-empty sequence. Okay. In a particular sequence. Like first I'm going from Mumbai to Delhi and Delhi to Pune. Like this.
Okay, it's reachable. Pune is reachable, right?
Yeah.
You meant.
Yes, sir. Now I got both these.
I have a train which go from Mumbai to Delhi. I have a train which goes from Delhi to Pune. That's it, right? So I can say I can directly go to Delhi from Pune. So in the case of direct matrix D, so that IJ will be one for Mumbai and Delhi. Is it okay? For direct matrix, M and D will be one, right? Again, in the case of
Yes,
direct
sir.
matrix, Delhi and Pune will be one because there is a direct train here. But in the case of direct matrix, Mumbai and Pune will be zero because there is no direct train from Mumbai to Pune here like this, right? There is no direct train from Mumbai to Pune. But in the case of this B here, what we are saying, I can reachable from Delhi to Mumbai. So again, Mumbai to Delhi will be one. Anyway, that is correct. Delhi to Pune is also, I can go. I have a train here to one. But Mumbai to Pune also I can go, na, here.
Yes, sir. It is also one in
Via
this.
Delhi like this, and then I will go like this. Okay. So we represent a matrix which we are taking whether we are reachable or not. Reachable means what? We can go to that particular station via number of stations. So non-empty sequence of a train. Taking 2, 3 trains, I can reach to Pune. So this is what this B is saying. Okay. Now let's see. N is what? Length of keys of direct. So direct is what? Direct matrix. So keys of direct matrix, right? So direct is what? IJ here. So what these keys will represent?
Value 1.
No, not one. Keys will represent simple.
Sir, stations. Starting and ending station.
Yeah, station it will represent, not starting and ending. Any station. If I have just 3 station in the graph, so it will represent Mumbai, Delhi, Pune only, right? So number of stations in the graph, that is basically direct keys. So and length will be number of station, that is 3 for our example. So we are going to create a matrix of 3 by 3 here, right? 3 by 3 matrix for this station. For each are in rows of direct and columns of direct. So same Mumbai, Delhi, Pune, BRC equals to direct RC here, right? So see here what we are doing here, right? So here R and C is what? Rows and columns is what? Mumbai, Delhi, and Pune only. Both are same here, right? So first R equals to M. So R equals to M, and then we will keep changing the value of C here. So first C is what? M. So do we have any trains from M to M? And then
No,
we can
sir.
update it to M to M. So anyway, that is 0, right? So 0 will update by 0, not an issue. Now next will be Delhi. Instead of C, it will be D now. Now Mumbai to Delhi and direct here R is what? Mumbai and C is what?
Yes, sir.
Delhi.
This becomes true and return 1.
So here R and C is what? 1, right? Again, C will be what? P. Again, Mumbai to Pune. Again, Mumbai to Pune. In a direct train, we have Mumbai to Pune. Direct, no, right? There is no direct H. So this will remain 0 here. In a direct R2P, Mumbai to
Yes,
Pune, I
sir.
don't have any direct, so that will be 0. That is going to get updated in the B as well. Okay. B will be a 0 in that scenario. So if you observe here, what this is doing, now here B and direct both are the same matrix basically, right? BRC and DRC, same
Sir.
same matrix. Right? For every value of R and C, we are simply updating it to direct matrix only. So as of now, B and R are both are same. Now we have one variable hope equals to 0, while hope is less than n minus 1. N is what? Number of stations here. So here we have 3, so we have 2 here. So 0 is less than 2. Yes. B is equals to one more hope B. So what is this one more hope? We have a procedure here, right? And what we want to do, same thing here, right? So let's see. For each R in rows of B same MDP, Mumbai, Delhi, Pune. What happened? So this will be again Mumbai, Delhi, Pune. So R equals to Mumbai, C equals to Mumbai for the first iteration. Fill in the choice. So we have to fill, and then we have to return B. Okay. So what B will return? Let's see here. So B will return that particular value, and hope will be hope plus 1. We'll see that what is this. But what B is representing, that is clear. What is B here from this one? Because we have to fill the code, so we should understand the question here. B represent if J is reachable from I. Is Mumbai reachable from, sorry, is Pune reachable from Mumbai or not? That is true. I can go from Delhi first and from Delhi to Pune. Can I say, am I reachable to Delhi via Pune? Can I go to Delhi from Pune?
No, sir.
No, there is no train from Pune to Delhi, right? Or then Pune to Mumbai. If I have Pune to Mumbai, then I can say I can go to Delhi via Mumbai. First, I will go to Mumbai, then I will go to Delhi. But I don't have a train here, right? So let's see. We need to fill that pseudocode first. So let's take option number A. For each K in columns B, R is what?
Rows.
Yeah, M, and C for each K in column B. So yeah, column B will be same MDP, right? But here we are saying for each K. So RC equals to 1. If RC equals to 1, exit the loop, right? If there is direct train between R and C, then we are going to exit the loop. This is what it is saying. Okay. It means that if I can go from Mumbai to Delhi, exit the loop. If I can go from Delhi to Pune, exit the loop. But what about this Mumbai to Pune? In the case of B initially, it is equal to same as D only. I cannot go directly from Mumbai to Pune. In that scenario, this will be false. If it is Mumbai, if it is Pune, it is not equals to 1. So this is false. Let us go for this one in that scenario. R and K, right? So here R is this one, M. And what about C? C was P. Are you getting my point? What I'm doing here?
Yes, sir.
Yes, sir, it's clear, sir.
See, BRC equals to 1, exit the loop, right? But initially, both the metrics are same. Direct and indirect, both metrics are same. So, but Mumbai to Pune, there is 0 only in both the metrics, right? So, we are not going to exit the loop in that case only Mumbai to Pune because that is 0. So, this is false. So we are not going to exit. Now, let's go here. So, here M is, so R is M and here C is P. Because of this condition, it is false. Now, for what value of K, this will be true. So M to K is, there is H from M to K. Again K to P, there is one H. Can you see this condition here? M R to K and K
Yes,
to
sir.
C. It means that I can go from M to P via K. Right? This is what we are doing. R again P equals to 1. Then we are exiting the loop. MP is this one. It means that I can go to RK. So RK and then K to C. It means I can go to R to C via K. This is what this particular if condition is checking, right? So we are updating that particular matrix to 1. Then we are exiting the loop. That is correct here, right? So we are doing this. Is option A correct? Yeah, A is correct here. Okay. Anyone any doubt in this question? Any you are not able to understand what we are doing here? No. Okay. Great. So just remember this example. Direct matrix is what? Simple. We are keeping a note whether there exists a direct train between two stations or not. Mumbai, Delhi, yes. Delhi, Pune, yes. Mumbai, Pune, no. Pune, Delhi, no. Pune, Mumbai, no. Okay. What about B, B is keeping a track whether I can go to Pune via any particular station or not. Mumbai, Pune, I can go. Yes, Delhi, but Pune to Delhi I can go. No, because there is no train from Pune to Mumbai to go. Right. So this is what we are doing here. Again, what about option number B here? Same. For each k in columns of B will be MDP, Mumbai, Delhi, Pune, and let's say for any value of k, R equals to K equals to 1 and B equals to 1, then we are saying RC equals to 1. Same thing. I am going R to K, Mumbai to Delhi, and then again Delhi to Pune, K to C. If I'm going from R to K, K to C, it means I'm going from R to C. That is also correct. B is also
Yes,
correct
sir.
here,
It's true, sir.
right? Now what about C? Rows of B, same thing. Uh, R to K, K to C, R to C, other rows or column, anyway, it will give me the list of those things only, right? Doesn't matter. Anyway, it will be MDP only, what are the station we have taken. So C is also correct. What about D? For each R in columns B, again MDP, K to R. I can go to K to R. I can go to K to C here. It means I can go to R to C. Is it correct? No, right? I can
No,
go
it
to
is
K to
incorrect.
R. I can go to
False,
K
sir.
to C, but it means it doesn't mean that I can go to R to C, right? So option D is not correct. So now I hope you understand the difference between the other option here. So here it is for option number D. And here what we are doing R to K and K to C. Then I am saying I can go from R to C here like this. But it is not correct here, right? So that's why option D is not correct. Simple. Understand the question first. Nothing in that. It was just checking your understanding of the problem here. What this direct station is, what this reachable thing is, right? So this is what it is. Okay, great. So let's solve question number 7. So consider the following graph. N equals to 5. This is given to us. Matrix B is computed using the above pseudocode. Okay. What is the sum after executing this following pseudocode? Tell me. Matrix B is computed. N is basically 5 here. So what is the sum? Value of sum? Where it is sum? Yeah, code is there. Yeah. Sum equals to 0. For each R in rows of B, for each C in columns of B, sum equals to B plus R. So rows of B and columns of C will be what? 0, 1, 2, 3, 4. So it will be 0, 1, 2, 3, 4. This will be also 0, 1, 2, 3, 4. Right? And what we are doing, if there's H from R to C, we are saying 1. Right? So first R will be 0 for the first iteration, and then we are comparing with all the values of C for the inner for loop. So 0, 0. Do we have any H? 0 to 0?
No,
No,
sir.
sir.
No, because remember we are considering the B here, right? There is, can I go to 0 to 0?
No, sir.
Oh, no, sir.
What? Okay.
Sir, can we go, sir, via 1, 2, 3, 4, and again
This is
return
what
back
I am
to
saying. Can I go like this to 0 to 0,
Ah, yes, sir.
right?
Yes, sir.
Here you can see what we have done here. So we are going for all the hoops. We have just checked for this code. Only one intermediate station, right? But what if we have this one also? Let's say Pune to Bangalore. So can I say I can go to Bangalore from Mumbai via Delhi and Pune?
Yes, sir.
This is also possible, right? So Bangalore is reachable from
Sir.
Mumbai. I can say via Delhi and Pune. So same thing. Can I go to 0 to 0?
Sir.
Yes, sir, we can.
Yes, we can go. So that will be 1. Now change the value of C to 1 instead of 0. Now 1. Can I go to 0 to 1?
Yes,
Yes.
sir.
Yes, sir.
Plus 1. Can I go to 0 to 2?
0.
Yes.
Yes, sir.
0 to 3? Yes. 0 to
Yes,
4?
sir.
Yes. That
Yes,
will be
sir.
5. So 5 for 0. Okay. For R equals to 0. But if you observe, I can go to any node from any node. I can go to 1 to any other node. I can go from 2 to any other node. Same for any other node, right? As 0. So here also 0, I got 5 things for all the 5 nodes. Similarly, for other 4 nodes as well, it will be 5, 5, 5
Okay.
like this.
5. So 25 is the answer, sir.
25 will be the answer like this. Okay.
Okay, sir.
Because for every node, I can reach to all other things, right? Self also and other node as well. So that will be 5. And this is for all the nodes. So in this way, we have a 25 as the answer. Okay. So please try to again solve this question. Now let's move to question number 8 and 9. Anyone, any doubt in this question?
No doubt, sir.
Okay.
Sir.
Now the question 8 and 9. How many people are there? 26. I thought only 2, 3 people are there. Okay, great. The following pseudocode is executed using the train's data set as discussed in the lectures. Assume train is a dictionary with a train number as key. Again, same scenario given to us. In this example, train number starts from Bhubaneswar, ending station is Delhi via this much station, right? So common number L1, L2 returns the number of common element between the list L1, L2. So if I have two lists, the number of common elements will be written by this particular function, right? So let's say L1 is 2, 3, 4, 5, 8, 1, and L2 is 3, 1, 8, 9, 11. Now tell me the output of form number L1, L2. Yes.
3,
So number of
1,
common element between both the lists. So I have 3, I have
and
1,
1.
1.
I have
That's it.
8, 8. This is 8. Okay, I have 8
Oh,
also, right? So I have 3 elements
Okay,
in
sir.
common. So answer will be 3 here, right? So number of common elements. So 3 are the common element. This is the function. Okay. Now let's see the procedure. Do something. Trains I0 index dictionary for each T in keys of train. Again, keys of train will be my train number here like this, right?
Yes, sir.
So index T equals to I. So for that particular train, so keys of train will be a train number, and for each T means what? For each train number, and here you can see index T. So index empty dictionary, T is basically a Bhubaneswar equals to I. I is initially 0. And then we are incrementing value of I to 1. Again, we are going for a next iteration. For next uh, thing here. So what we are doing here, what is pseudocode? For each T in keys of train. Keys of train is what? Train numbers. So for every train number, we have, okay. So here we are keeping a track in the index like that for train number 12281. It is basically a, initially it is 0, right? Now next train number will be again 12283. So for that also, that will be 1, right? 12282 will be 1. 12283 will be 2. Is this happen? The output of this particular thing? Tell me. If I have
Yes,
this
sir.
much trains 12281, 12282, 12283. I have 3 trains in the trains dictionary. For each T, for this one, index will be the first, will be 0. So increment the value of I to 1. Go for next iteration. Next train number, corresponding value will be 1. Go for increment of I to 2. Next iteration, corresponding train number, this will be this. So what we are doing, we are simply giving the numbers to this particular train number in this order, right? So 0, 1, 2 to that particular train number. Okay, this is what this index is doing. And is what length of keys of index. Keys of index is what, how many train we have? 3.
yes,
3.
Length
sir.
is
Number
3.
of
So
trains.
again 3 by 3 matrix. For each T1 in keys of train, again keys of train here. So keys of train is what? Train numbers
Train numbers.
1, 2, 8, 1. And for every train number, again we have same thing here. We are comparing when train number should not be same. So for the first iteration, it will be 1, 2, 2, 8, 1. And here we have 1, 2, 2, 8, 1, 1, 8, 2, and 8, 3. So when T1 is not equals to T2, means when T2 equals to 1, 2, 2, 8, 2, okay, so both the trains are not same. If both the trains are same, then simply we are going for next iteration. This is what happened when For inner for loop, T2 was this one. So we directly go for next iteration. The next iteration is what? 82. Now, if train is not same, what we are doing here? CSTN. Now, what is CSTN? The matrix. We are going to update the matrix. What? Index of T1. So index of T1 is what? 12281. So that is basically a 0. Index of T2 is what? 12282 is 1 equals to common train of T1 and T2. So trains of T1 and trains of T2. So what this trains is a basically dictionary and T1 is a train number. So here if you see train number and this one and 12282 will be, let's say again we have Balasore, Mumbai, Chennai, then we have Kanpur, right? Now, if you understand what L1, L2 is doing, now tell me what this particular thing is doing here.
Sir, it's
Sir,
selecting number of common stations.
Number
yes,
of
sir.
common stations between these two trains, right?
Yes, sir.
So if you see for this 82 and 81, Balasore is 1 and Kanpur is 1, right? So
Yes,
output
sir.
will be in that case 2. So what this is doing, number of common station between those two train number. And we are going to update that for 0 and 1 in that particular matrix. So if I have this matrix 0, 1, 2, 0, 1, 2. So for here, it will be 2. So for this train and for this particular train number, between these two train number, there are two trains, right? So two common station here, like this. This is what is pseudocode is doing. You know, what is returning? That particular dictionary or matrix and the index. Okay. So both the things it is returning. Anyone, any doubt in this question? What is this
Sir,
index and what is the station?
sir, what is it returning? Could you explain once again?
It is returning both the things. Station means the matrix as well as the index here. Dictionary as well as the matrix. So this matrix will get
So,
filled.
uh, for this example, what will be the index, sir? Because we took two index 0, 1.
Yeah, for this example, if I just have three trains here, so index dictionary will be 122810, 122821, 122822. So number of trains we have, that is basically an index in that order. If I have 10 trains, so it will be like this 0, 1, 2. Then next for next 10 number, it will be 3. For next 10 number, it will be 4 like this. Okay. So instead of mentioning train number, we have just given 0, 1, 2 there. Okay, for that
Okay,
corresponding
sir.
train. This is what it is returning. Now let's see the question. If CSTN IJ is 0, for I is not equals to j, which of the following
Then
statement
no,
can be concluded?
no
There is no
common.
common station.
Yes, very
Common
good.
Yes, sir.
stations are
There is
present.
no, okay, no common station. So, but in the terms of sentence, let's see. There is no route between station with index I and j using one hope. Can I say like this?
No,
There is no
sir.
route between the station indexes using one hope. Using one hope means what? One intermediate station. So I to j I can go and j to k I can go, right? So there is no road between the station with the indices using using one home. That is not a correct one. Simple. It means that if it is equals to 0, it means there is no
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 common
common
train
intermediate.
between,
station.
no common station, sorry, no common
Yeah,
station
no
between,
common.
yeah. So there are no common trains. No, we cannot say there are no common station.
Yes, sir.
Yeah.
Yes, sir.
So right. So what is the correct option here?
Option
Yes,
C, sir.
sir.
It's above only.
C only.
Yes, sir.
Yeah. See here, right? None of the above. No trains.
Sir,
No.
could you explain option A, sir, once again?
There is no route between station with indices I and j using one hope. Yeah. So if this is I, if this is j, so I cannot go I to j using one hope. Means we have one intermediate station like this, not this one. Yeah. This is clear. So one hope means what? One intermediate station here. I can go to j via I. So I can go to j from I via k like this. So there is no route between. So it means that exit a route between I to j. No route means what? This thing is not present there, right? So you can say anything like I, k, m, j. Now I am going like this. Now here I can go to j from I, but we are k and m, that is two intermediate station. Not using one hop, using two hop, right? And there is no route, but here it is a route for j. We are two station, right? So this is the correct for this particular case. There is no route between the station I and j using one hop. Okay, one hop means in the case intermediate station between I and j, like this. So anyway, we are not talk about in the code, right? That is not correct. Now assume we start our journey using a given train T. Okay. Now assume we start our journey using a given train T. Now consider the following procedure should return true. It has at least one common station with all other train. Okay. Remember, it should return true when it has at least one common station with all other train. So following procedures. Okay. So procedure is this one: train boarding T, trains. So trains is what? Uh,
Trains.
yeah, trains is trains. Yes.
So
So
the
this particular,
dictionary,
the dictionary, right? This one, and this is the procedure. What this is giving us? What is returning? Common station and the index one, right? So this is it is returning. So we are taking that as an input. T is what that particular train. Let's say 1 2 2 8 2 here. Okay, and train is that entire dictionary. So CMAT index is basically this particular thing. So CMAT will be the CSTN output, and index will be the output that particular dictionary. Okay, and if you observe, we got that in the previous thing. Now k equals to index of t. Now what is index of t? 1, right? If you observe for 1 to 2 8 1, it was 1. Now for each I in columns of CMAT, again CMAT is what? That particular
Sorry
thing.
for the interruption.
Uh,
As there was two common uh, stations, so that's the reason index is 1. Am I right, sir?
no. Index is here because of this particular thing for each 10 keys of train. So we are simply giving the index
Oh,
number.
particular
Yeah.
train. Okay,
Yeah.
okay, sir.
It
Thank you,
means
sir.
that train number is present first in the train's dictionary. After this train number, this is present. After this train number, this is present. The sequence or order in which the trains number are present in the train's dictionary. That is basically a
Okay, sir.
index one. Okay, that is what it is. So it is a second train. So we are saying index will be 1 here because starting from 0, right? So for each n columns of CMAT, again CMAT will be same number of station. So what we are checking here, if I is not equals to k, so I and k. So what is I here? What is k here? So I in columns of CMAT. Columns of CMAT is what? 0, 1, 2, right? Right. Column is what we have. Yeah, this one, whatever the index we have created, right? So 0, 1, 2, 0, 1, 2. This 3 by 3 matrix here. So k is what? 1. When I is not equals to k, if that is true, and k to I equals to 0, then it is returning false. Otherwise, it will return true. Now, whether this particular procedure will uh, give me the required thing, it will return true when it has at least one common station with all other train.
I think it will return false.
No. We need to see. Yeah,
Sorry,
it should
it
return
will.
true.
Yeah.
When I can say there is a common station between all other train for that particular train T. So if you see this matrix, if you understand here, for this particular matrix, for this particular train number 1, if I have any index value for which we have some value, either 1, 2, 3. So 1, 2, 3 indicates what? Number of common trains, right? Here,
So,
what we have discussed here for this 0 and 1, we got two trains here, right?
so,
So for those, there must be some value, either 1 or 2. But here we are equating to 0. It means for that particular index number and for any index number for 0 or 2, if it is equals to 0, then it should return false. That is true or this is correct or wrong according to a given condition. I want to return true when there's exists a common station between two that particular given train or not, right? So if there is no
It's
common
true,
station,
sir.
yes, if there is
Yeah,
a
it's
common,
returning. Okay, sir.
no, tell me, go ahead.
No, no, I was trying to say that when this returns true, because the above condition is not satisfied. I mean,
Uh,
the starting point. I mean, no, no, the
no, you are
common
correct. Go ahead.
points are not starting. The comments are not equal, so there is no comment. So that's the reason we are getting false like that.
Yeah. So when we get false, when this condition will become true, right? When
Ah,
this
yes,
condition
sir.
will become true only when there is no common station, right?
Yes, sir.
If there is at least one
That's
common
what I'm
station,
trying to
that will
say.
return true. So this should be the correct one, right?
Yes, sir.
If there is a
Yes,
common station, if there is no common station, then it should return false. That is, it is doing, right?
sir.
Let's see. Option one looks okay. What about option procedure two? Same. We have trains T count 0 for each T2 in keys of train. Keys of train will be that 12281 and then 12282. Common train T1 and train T2. So this T and this T greater than 0. If it is greater than 0, then we are counting.
And at least one.
Yeah. So common number will indicate number of common trains between this train and any other train. If that is greater than 0, then we are counting. Okay. We are doing this for this one. Let's see. If count is equals to length of keys of train, then we are going to return true. Otherwise, we are going to return false. Is that correct?
No, sir, this is not correct.
If there is at least one common station between this one, so it will be one for at least one, or more than it can be two, three also. This will be true. When we are counting, counting will be
That
equals to
make
one.
any sense?
Huh? Yeah, but what about this length of keys of train? Length of keys of train is what? Number of uh, stations, say
Trains.
number of trains
Yes, sir,
only, right?
number of trains.
Number of
Three. So
lines.
yeah. So if that count is equals to three, why we are comparing this, right? I don't think it is required. So
There's no any sense.
yeah. So count is what? It's count is different. Count is simply how many times that particular train. Like we are comparing that train with all other trains having common station, right? So that is a count. But we are comparing count with all the number of trains. That is going to return true. So I don't think option procedure two is correct one. So only procedure boarding one works correctly. Let's see if both procedure works correctly. Okay, how? Let's see now. So at least one. So that is getting correct here. So let's see 12283 as well, and T is basically my 12282. So T2 will be what? This one first. So there is a common train between T and T2. If there exists common train, then it will return count one. Go for next iteration. Again, same T is there anyway, all the will be common. So again, it will return count two. If for 8 if we don't have any other common, so that will anyway going to return 2 only. So count will be 2, but here will be 3, not correct, so it will return false. But this what's the required thing here? Return true when at least one common
One
station
common
with all
station.
other train. With all other train we want, right? Yeah, okay. For all other train we want. Yeah, correct.
So it's true, sir.
Yeah, so this particular train should have a common station with this also and this also, right? Then only we can say it should return true. So above thing also for KMAT. Yeah, this is also working for all the trains. Yeah, we have only checked for one train, but this will return for all other trains. Here also, if you see for this train number, if it is common station between this one, so count will be one. Common between this one, so count will be two. And anyway, it will be common with itself, right? So same station. So in that scenario count will be 3 and number of trains are 3, so then it is going to return 2. Yeah. So I have missed this point. All other station. Yeah, that is correct. All other train.
Sir, I have a doubt. Sir. In
Huh?
second option,
Yes.
can I say,
What
sir?
is?
In the in the train data in trains dictionary, there should be a T for T1, right, sir? In
There
the
should be. Can you
input
repeat?
parameter. In train list, in train dictionary, there should be a T1 key, T key, right, sir?
This is
Hello?
a train dictionary here.
Yeah, sir. In that train dictionary, we have a
Hmm.
T as a one of the key. Am I right, sir?
Oh, yeah. For that particular question, T is basic one of the train. Yeah.
Yeah, one of the key, right, sir? One of the
Train
key in
number.
train dictionary.
Yeah. This train number is one of the key for train dictionary.
Yeah,
Yes.
sir.
Yes. Then
Then how it will be equal to the length of the train, sir? Length of the train means then T1 also be in T1 also will come to the dictionary. Count may not be equal, right, sir? For any such case, sir. For any such
no,
case,
keys of
it
train
may
will be
not
what?
check.
No, that you correct. If you see that key will also get consist here. So if I just have 3 trains here, so keys of train will be 3, length will be 3 here, right? But here we are comparing with itself also, na? T2 is equals to T2 also, right? So here in the keys of train, here also we have all the 3. So T is 12282. Again, when we are doing this for loop, again for the second iteration, 12282 will come. So train of 12282, 12282. So we are comparing the same train with the same train. So anyway, that will be a greater than one same station are there, right? So then we are also incrementing the count. We are considering
Does it
that,
make any sense while comparing the same train?
yeah, this is what this function is doing. We are comparing the same station of the same train. So anyway, number of station will be same, common station, right? So greater than 0. So we are considering that also count here. So that's why we have considered the length equals to 3 here. This is also correct. In the previous procedure, we have not compare the same train. I is not equals to j. I is not equals to k, right? But anyway, that is the same number of stations there, right? So we can consider it with all other trains. Okay. So here we are not consider particular thing, same train, but here we are considering the same train also. But that doesn't make any sense because anyway the number of station will be same, right? This is greater than 0 as always. So option, yeah, option 2 is also correct. So C will also work correctly. So remember with all other trains here. Okay, so in that scenario, that is correct. Anyone, any doubt in this question? So there are
So,
many good things in this particular assignment. So please try to solve by your own. We have discussed, but if you try to solve again, you will get some doubt. Okay. So here I'm explaining one by one. So that's why you feel it is easy and you are
Excuse me,
able to
sir.
understand. Huh?
Hello.
Bolo? Yes.
Sir, actually, which segment very high percentage in terms of
There is no
weightage,
fixed.
question
No,
weightage?
there is no fixed weightage. So week 1 to 12, everything is included. Okay.
Oh, week two.
Yeah, so there will be 20 questions, and but you can expect around 5 to 6 questions from later week, 8, 9, 10, 11. So these 4 weeks, 5 to 6 questions will be there. 7 questions also can be possible. Okay.
Okay.
12 means only we have 11 week only. 12 is nothing, just some tutorials are there. There are no question, only tutorials. So
Yes, yes,
if you
we
are
are.
facing issue in understanding dictionary, so please go through week 12 also. There are some tutorials based on that. So please try to solve the question again. Okay. So you think that you understand, but if you again solve this question, you may face some issue. Here I'm explaining, that's why it's look easy, but you need to solve again. Okay. So in this way, you can avoid that exam situation that Divya was saying. Okay. Great. So that's it from my side. Okay. So please
thank you so much,
watch
sir.
the lecture and solve the question again. Yeah.
Okay,
Thank you,
thank
sir.
you so much, sir.
Thank you. Thank you, everyone.
Thank you, everyone.
Yes.